we're going to have a look at how to solve simultaneous equations. Now, simultaneous equations, as you can see here, are equations where you have more than one equation and also more than one variable. So in these scenarios here, you see we actually have two variables, x and y, and we have two equations. So if you have two variables, two unknown values, you will need two equations in order to be able to solve the system. So this is our introduction to simultaneous equations. To get started, I'll go through a very basic example here. Question 1, part 2. X plus 2y equals 5, x minus 2y equals minus 3. So let's have a look at this example here. So the easiest way to get started is we can just add the two lines together. For this example, all I need to do is add the two lines together. The reason will become clear in a second. So if I add the lines, x plus x makes 2x, plus 2y minus 2y is no y. That adding 2y and subtracting 2y cancels out, equals, and then 5 take 3, that's 2. Okay, so now we've simplified it. We just have 2x equals 2. So if 2x equals 2, we know we can divide both sides by 2 here and get x is equals to 1. So that's our solution for x. We have x is equals to 1. However, we're not finished yet. Look at the equation. We had x and y. So once you solve for one letter, in this case we solve for x, we have to find out the other letter as well. So we still have to solve for y. The easiest way to do that is by substitution. So I'm going to take that first equation again. The first equation we had here, x plus 2y is equals to 5. Now don't forget, we know that x is equals to 1, so we can sub 1 in for x here to figure out what y is. So since x is equals to 1, we're going to take this line and call it 1 plus 2y is equals to 5. And then we can just solve the mini equation we have here. 2y therefore is equals to 5 minus 1. 2y is equals to 4, so y is equals to 2. So that's our second answer. So notice here our two answers. We had x is equals to 1 and y was equals to 2. So all I had to do here in this example was just add the two lines, because the plus 2y and the minus 2y cancelled out, leave me with just x's. So this was a very simple introductory example. So let's have a look at a slightly more difficult example. The next one I'm going to go through with you guys is this question 2, part 3. 4x plus y equals 11, 3x minus 2y equals 11. So 4x plus y equals 11, and 3x take 2y equals 11. Now, in the previous example, what did I do? I just had to add the two lines. X and x made 2x. But when I added the two lines, because I had a plus 2y and a minus 2y, adding 2y and subtracting 2y cancel each other out. I was just left with x's. But you can see here, 4x and 3x will make 7x. Y and minus 2y will be a minus y. So I'm not getting anything to cancel if I was to straightforward just add these two lines. It would be much better for me if this value right here was a plus 2y. If this was a plus 2y, then it would cancel with that minus 2y when I add the lines. Now the good news is, because this is an equation and we can multiply equations by whatever we want, I'm going to take this first equation and multiply it by 2 in order to achieve the plus 2y that I would like, to get the lines to cancel, or to get the y's to cancel when I add the two equations. So after I do that, rewriting the first equation, I've multiplied it by 2, rewriting it, I will get 8x plus 2y is equals to 22. So I've multiplied the first equation by 2. And the second equation I'm going to leave alone. I'm just going to write that one out again. 3x minus 2y is equals to 11. Now I can see if I add the two lines now, the plus 2y and the minus 2y will cancel out like I needed to. So adding the two lines, 8x plus 3x, that's 11x, plus 2y minus 2y, cancel, equals 22 plus 11, 33. So if 11x is equals to 33, then dividing both sides by 11, I will get x is equals to 3. So now I have my x value. Once again, I still have to find my corresponding y value. In order to find that, we'll fill our x value into one of the original equations. So I'm going to stick with the first equation here, 4x plus y is equals to 11. Now don't forget, I know that x is equals to 3, so I'm going to sub 3 in for x, getting 4 times 3 plus y is equals to 11. 12 plus y is equals to 11. So y is equals to 11 minus 12. Y would equal minus 1. So there's my second solution. So I have x is equal to 3 and y is equals to minus 1. Let's look at one more example. We'll step up the difficulty level a little bit more. The one I'm going to look at with you this time is this part 2 here. 3z plus 2w equals 24. 4z plus 3w equals 33. So remember, the idea is we want to add the lines, but after adding the lines, we're hoping that either to eliminate the z's or to eliminate the w's. So we want to eliminate either the z's or the w's when we add the lines. So remember, in the previous example, I wanted to eliminate either the x's or the y's. And what I did was I eliminated the y's because I multiplied this line by 2 to get a plus 2y, and the plus 2y cancels with the minus 2y, eliminating the y's, leaving me with just x's. So in order for the variable to get eliminated, you need to have the same number but opposite sign, because they'll add to 0. Plus 2 minus 2 will add to 0. So we want to achieve that here. So I'm going to get rid of my w's. I'm going to eliminate the w's. So the easiest way to do that, if I have a 2w and a 3w, I'd have to multiply each line, and I want to achieve the same number with opposite sign. You'll see what I mean here. So I'm going to multiply this line by 3, and that will give me a plus 6w. And if I multiply the second line by minus 2, that will give me a minus 6w. So let's have a look then. So multiplying the first line by 3, I will get 9z plus 6w is equals to 72. And then multiplying the second line by minus 2, I will get minus 8z minus 6w equals minus 66. And you can see why I did that. Now when I add the lines, a plus 6w and a minus 6w will cancel, therefore eliminating the w's. So adding the lines, 9z minus 8z, that's simply 1z. Plus 6w minus 6w eliminate each other. And 72 minus 66, that's 6. So in other words, we now know that z is equals to 6. So we've got our first variable solved for. Z is equals to 6. Now remember, once again, once you solve for one variable, you have to fill back into one of the original equations to solve for the other variable. So I will fill back into the first equation again. So we had 3z plus 2w is equals to 24. Remembering that z is 6, so filling 6 in for z, I will get 3 times 6 plus 2w equals 24. 3 times 6, that's 18, plus 2w equals 24. So 2w equals 24, take 18. 2w is equals to 6. So dividing both sides by 2, we will get w is equals to 3. So there was my two solutions in this case. We had z is equals to 6 and w is equals to 3. So as you can see here, the whole idea with simultaneous equations is you want to eliminate one of the variables. In order for a variable to be eliminated, we have to have the same number but opposite signs. Then we have to add to 0. Plus 6 minus 6 would be 0. In our previous example, we had plus 2 minus 2 to give us a 0. So that is our introduction to simultaneous equations. The best thing for you guys to do now would be to practice some of these questions. Check your solutions online. And for access to questions, solutions, graded quizzes and more, visit www.eliminmaths.com.